Assalamu alaikum everyone. I hope you guys are doing great. So in this class, we are going to talk about vectors. We have been talking about vectors in the past week, and today we will discuss distance of a point from a line. Okay. So let's get started. Okay. This is basically the last unit of this chapter. It is 9.8. The distance from a point to a line. This is what exactly we need to talk about in this class. Okay. Now for this, you can think about multiple scenarios. So for instance, let's say this is a line and the equation of line is R equals A plus TB. So A is a point and T is basically A is the position vector of a point lying on the line, and T is basically a constant or it's a scalar, and B is another vector that's basically the direction vector of the line. Okay. Now imagine that we have a point right here and you need to find out this distance, the perpendicular distance of the line from the point. Okay, this is what we need to study in this class. So we will assume that there's a point and the position vector of that point would be A plus TB. We would be having A and B in that case, and you would be knowing this point, the coordinates of this point would be given. So by taking the dot product and equating it to 0, we will find out the value of T. Why am I taking the dot product and why am I equating it to 0? Because I know the two lines are perpendicular, and whenever I will take the dot product of two perpendicular lines, the theta is going to be 90 degrees and cos theta is going to be 0. So always remember the dot product of two perpendicular lines is going to be 0. So the note or the rule is dot product of two perpendicular lines is basically 0. This is something that you need to always remember because we will be using it time and again. Okay. All right. Let's talk about an example just so things get better. Question number 1. Find the distance of the point P331 from the line L whose equation is R equals -430 plus T into 1 to -4. All right. This is what exactly we need to talk about. Okay. So we have a point and we have a line and we need to find out the distance of point from the line L. Okay. Again, the idea is same. For the solution, let's understand the diagram. So this is your line and this is the point P. The rule is still the same. I need to find out this distance right here. For this distance, I need to have this point Q. And initially, I am just going to make an assumption and say that Q is minus 4 plus T, 3 plus 2T, and minus 4T, right? I'm just going to take this as Q using T and I'll see what coordinates or what value of T I get when I use the assumption that the dot product of the direction vector of the line 1, 2, minus 4 and PQ is equal to 0. So Q has coordinates minus 4 plus T, 3 plus 2T, and then we have minus 4T. These are the coordinates of Q. How do I find PQ? P has coordinates 3, 3, and 1. These are the coordinates of P. I need to have PQ now. I'll tell you why. Just trust my words and know way to work on PQ. So the vector PQ is basically going to be OQ minus OP, and this is going to give you minus 7 plus T. Let me write it down properly. Minus 4 plus T, 3 plus 2T, and minus 4T minus 3, 3, 1, and upon simplification, the vector PQ is going to be minus 7 plus T, 2T, minus 4T minus 1. This is going to be the vector PQ. Okay, we are done with this part. Next, I know that since PQ is perpendicular to the line L, so their dot product is going to be 0. So the direction of L is, or the direction vector of L is 1, 2, and minus 4. PQ dot 1, 2, and minus 4 is going to be 0. Okay. And now let's plug in the values of PQ that we just got. Minus 7 plus T, 2T, minus 4, T minus 1, dot 1, 2, minus 4 is 0. And this would imply minus 7 plus T plus 2T into 2 plus minus 4T minus 1 into minus 4 is basically 0. This would give you minus 7 plus T plus 4T plus 16T plus 4 equals 0. And T is going to be 1 by 7. So T is 1 by 7. So this means that the vector PQ was this. So T is 1 by 7. So PQ is going to be minus 7 plus 1 by 7, 2 into 1 by 7, and minus 4 into 1 by 7, minus 1. And finally, in order to find out the distance, let's just simplify this first of all. PQ is going to be minus 48 by 7, 2 by 7, and minus 11 by 7. And how do we find the distance? For the distance of any vector, we use the mod function, and that is basically going to be minus 48 by 7 squared plus 2 by 7 squared plus minus 11 by 7 squared. We are going to square all of it, and this is going to give you 2429 divided by 7. And this is basically the answer. This is basically the distance of the point from the line. Okay. Okay. All right. So this was basically the idea. Now, in this question, always remember, you can certainly come across a question of this type in exam as well, where you have a point and you need to find the distance of the point from the line. Always remember, talking about the perpendicular distance from the point and the line, that is mandatory. That is something that you need to remember. And other than this, just follow the idea that first of all, you need to use the dot product to find out that very specific value of t, which would give you this point Q, such that PQ would be perpendicular to line L. So first of all, we will take the points P and Q to find out vector PQ, and then the direction vector was already given. We have used the dot product, and that gave us t equals 1 by 7. Once we have the value of t equals 1 by 7, I got the vector PQ. And once I have the vector PQ, I am only left with finding out the distance or the length of PQ. So I've used the distance formula, and this gave me the answer. I hope you guys were able to understand the idea. We are done with the ninth chapter, that is vectors. You will find all the videos and everything in the um, link in description, or you can just get yourselves enrolled for the live session. In case of any queries, anything, just comment down in the comment section, or you can directly just ask me questions again by using the link in description. I hope that you guys like this video. Then I'll see you next time with another video. Take care all of you, and have a good day. Allah Hafiz.